talking about data science. I've just been giving you a brief overview of data science. Data science is very large, and if you've been following recent trend, you know that data science is one of the trending things. Everybody wants to do data science, everybody wants to learn data science without understanding what it is and what it entails. People confuse things like data science, data analytics, machine learning, artificial intelligence. These are all different buzzwords associated with technology. I would attempt to explain this, give you a background to it. So to talk about what I will talk about today. So for content, like I said, data science is very large and very wide, and I might not cover everything that you need to know about data science, and that's why I've included my YouTube channel. So if you click on the QR code, you'll see a link to my YouTube channel where I discuss in depth about data science, how to get in, the skills you need to learn, and even teach you some things for free. The first speaker mentioned about if you want to learn data science, not advised not to go on YouTube because you could get easily lost. I think that was one of my motivations for beginning data science, to beginning my YouTube channel, because I felt like when I started there was lots of information out there that could get you confused if you don't have a sense of direction. So what I try to do is provide that sense of direction and guidance for people that wants to go on that similar field. So I have a playlist called Python for data analysis. Takes you from the basics, and if you follow through step by step, you should be able at least to do some basic things as well. I also have my GitHub. I'll share that later towards the end of the presentation. Just show you some content, some Python scripts I've done before now on machine learning, log analysis. So you could also go, and some training materials as well, and data set as well, where you could go pick up this to pick up any of the Python notebook or Jupyter notebook and follow through, and it would also help you. So as part of content, what I will talk about today, I'll tell you what data science is, who a data scientist is, and what they do, and what methodologies they follow, and some general tools, because there are lots of tools out there that you can use, but depending on what you want to do. So I'll give you, okay, if you want to use these tools, what factors contribute to the tools you should start learning, or the tools you should go for. Then I also talk about data, because a lot of people confuse data. What data is, give you some basics of what data is and how to get, if you want to get data, where do you get data from, what kind of data should you be looking out for. And also we try to touch some practical sections starting from the basics, so that at least you see the first speaker gave you some possibilities of how you can start applying. But we can now start. Okay, let's even start. We're starting from the basics. Where do we start from? What do we do? How do we get what we need to get? Okay, so first of all, what is data science? It's a science, and it's a process of extracting, of studying data. So you get data, you study data, you extract meaningful insights that would help business make decisions. So there are different industries, different sectors that require data analysis to draw information. A lot of times information is hidden in data, inside data, but you need to explore the data in order to bring out those information. For example, if you have a well and the well is declining, well production is declining, in some cases you may not really know why it's declining, or you should, let's take it out from oil and gas. For example, you have a business and you have noticed that your sales are declining. You wouldn't know why the sales were declining unless you pick up the data and start, because the answers you need are hidden within the data. But if you don't ask the data questions, like if you don't explore the data, you won't be able to get the answers you're looking for. So that's where data science come in, where you study the data to extract this information, and this information can now help you make predictions, make you understand, analyze the business needs and how it can help the business. Data science is a multidisciplinary approach, so you combine different things. So you can't say I know XYZ, then I'm a data scientist. It's a combination of different things. There is the mathematics. I know a lot of people ask, when they hear of mathematics, they try to run away. You can't do without it, but at the same time, you don't need complex mathematics. Yes, knowledge of mathematics is good, but at least the basic mathematics is very important. I tell people, if you know how to calculate the money in your bank account, or you go make a purchase and you know how much to give and how much to receive, at least that's good enough. Mathematics, you also need statistics. You want to understand what's a mean, what's a median, measures of central tendencies, measures of variability. Those are some important concepts you need. Then also machine learning, you need knowledge of machine learning, you need knowledge of artificial intelligence, you need computer engineering, that's programming, and also very key domain knowledge. Whatever you do, domain knowledge is very important. If you want to analyze, for example, you want to analyze well production, you need to understand the production engineering, for example, or reservoir engineering, to understand what do I want to see. So you can pick up any data. It could be medical data, build some meaningful charts. Sometimes if you don't understand the domain, some of those charts may not make sense, and you may not be able to bring out all the information you need on that chart, except you have that background knowledge. So that's why domain knowledge is very important in data analysis or data science. Okay, then let's go. Now the question is, who is a data scientist? Data science is the discipline or is the field, while data scientists are the practitioners, those people that actually analyze the data, explore data to bring out trends from the data. So I wouldn't really go through all this. So as a data scientist, what do you need? What should you know? I said you should know these things. First of all, I'll just focus on the things I highlighted in bold. So you need to know how to ask questions to identify the business pain. So what's the questions you're trying to analyze? You need to know how to analyze data. So I love the way the program has been structured, so where you have data analysis at the beginning and machine learning at the end. So data science is more like combining these two fields together. So you do data science, you also include machine learning in it to make predictions. So it's like a combination of, so like I'm like an anchor point for the first speaker and the last speaker. So you need to know data analysis, you need to know how to prepare data, you need to know how to transform data, you need to know how to extract insight from the data, and also most processes needs to be automated. So if you see things doing, one good thing about Python, one key point of Python is about automation, or data science is about automation, rather than trying to repeat things over and over again. It's just about setting up processes that automate that process. Then you need to also tell stories. Storytelling is very important because you can create good analysis, you do good visualization, but if you're not able to communicate your insights effectively, because sometimes some people you're trying to communicate to, they are not data scientists. So if you come and start speaking the data science jargon, you may lose your audience, you may lose your stakeholders. So you need to understand, how do I tell, yes, I found this complex information or complex insight from the data. So how do I translate that to something that a layman can understand? That's very, then also you need to solve problems. So you know how to solve problem. Problem solving is a key skill of a data scientist. Then finally, most times as a data scientist, you collaborate with a lot of people. So most times you collaborate with data analysts, or you collaborate with maybe software engineers and other domain experts. So you need to know collaboration skills. You don't have to, it's more also like working in a team. So you wouldn't say, I'm a silo worker, I like doing my things by myself. That wouldn't help you if you plan to go into any data related field, because you need to collaborate with different disciplines in order to bring like a unique product. Okay, so now just go into, so we've talked about what data science is, we talked about who a data scientist is. Now we want to talk about, so what do they do? First of all, I'll just go through, they manage data. I'll just go through this in they do data transformation. I'll explain them shortly. Then you talk about data visualization. They build models, they evaluate models, and they monitor models. So now let's go back on data management. Data management is about collecting data. Most times data comes from different sources. So it depends on the industry you're working on. For example, if you're working with a social media industry, like in the social media space, for example, you can get data coming from Twitter, Facebook, Instagram, and most of the times different data sources comes in different formats. So you should know how to collect the data and store it securely in a particular location. So if you want to start doing data management, you also want to look at things like SQL, handling structured database and unstructured databases. So you have to collect data, store it in a database. Then you can now start looking at data transformation. In most cases, where you extract, like I mentioned, that data comes from different sources, and sometimes and most times the different sources have different formats and different nomenclatures. So you want to know, okay, if I extract this data, you want to also transform it so that you have like a uniform structure for your data generally. So that's where data transformation comes in. They call it the ETL process. So you have the extract, transform, and load. So you extract the data from the different sources, you transform the data so that you have a uniform look of the data. Then you load the data. In some industries, in some companies, they use extract, load, and transform. That's ELT. But the general one is extract, transform, load. Then you save it in the central. The data you've transformed, you load it in a central repository. In most cases, it's called warehouse. So you have data lakes, database, and you have data warehouse. Most times, data lakes is where everything is just dumped. Then your data warehouse is where you've cleaned up the data that your analyst can pick and start using. From data transformation and integration, most data integration and transformation, then we'll start looking at visualization. So if I've collected the data, I want to see what I have in there. So you kind of represent your data graphically, and there are different ways to visualize your data. And let me just show you some examples of visualization. There are lots of visualization out there that you can use. So depending on the question you want to answer or the insights you want to see. So for example, you want to see pie chart. Pie chart are used to show proportion. So for example, I want to maybe if I want to take a database of people attending this call. We have males and females. So if I want to represent what's the proportion of male to female I have, a good way to look at that would be a pie chart. It just shows you that data proportion of different categories within your data. You also have bar charts. You want to see maybe the count of different let's say for example we have different schools present in this call today. I can say, okay, if I get the data of the people names and their school they represent, I can say, okay, let me do a bar chart of the number of the schools represented. The higher bars represent people that had the school with the highest population. So that's how you then you also do column chart. Column chart is also like a bar chart depending on what you want to see. Then you have a line chart. Line charts are used to show trends. I want to see, okay, for example, if you are working with let's say an oil and gas field, for example, and you have this particular well, when you say, okay, how much has this well produced? You can say, okay, daily production of this well. So, okay, maybe on the first day the well is opened, you see the chart. You can now say, okay, the trend. So, okay, maybe with that you're able to spot. For example, you have a lot of wells. If you do a line chart of the different wells, you can say, okay, maybe this well is performing better than other wells. You can say, okay, maybe within a particular time, the production for this well dropped. You can now start asking yourself, why am I seeing a reduction in the production of a particular well, a particular field? These are where some questions you can start asking, okay, if this was a well shut in, do I need other enhanced recovery method to increase production from this well? So those are some of the things you're able to analyze trends over time. Then you also have area charts. You can also use it to show trends, but when you're plotting differently, you can see the area distribution of the plot. You also have a donut plot that shows you, it's like a pie chart as well, but it's just in form of a donut shape. Then you have tree maps that just shows you subdivision of different things. You have bubble chart. It could also be a scatter plot. A scatter plot where you are plotting two x against y. For example, I want to see the trend of between two variables. You are comparing two variables to say how do they differ. So I want to see, are they correlatable, are they not correlatable. Then the bubble chart is more like a scatter plot, but maybe you're introducing a third dimension where you say, okay, for example, if I want to plot x against y, let's say I want to plot neutron versus density. At the same time, I want to know if they have high gamma ray or not. So the bubble size could be the gamma rays, where you have big bubbles. Okay, big bubble represents higher gamma ray, and smaller bubbles represent smaller gamma ray radius. So that's how you can use these different plots. I don't want to go deep into explaining everything, but just wanted to show you some kind of key charts you can come across and what they are used for, so you can always go back to read about them. So okay, if I want to start doing analysis, you want to say, okay, what do I want to what plots? Because doing data analysis, data science is not just about creating plots as I want. It's about what question do I want, what insight do I want to communicate. And there are different plots that shows different, like I explained for pie chart. If I want to show distribution, I want to show proportion, it's better to use a pie chart that would communicate my analysis better. So it all depends on your understanding of the data, your understanding of data analysis processes, to know what kind of chart will communicate my idea better. Then we'll also go down to, so after data visualization, then you can now start looking at, okay, building your model. In some cases, data visualization, data transformation might go hand in hand. Maybe after visualizing your data, you feel like, okay, I need to transform certain things, but that's when you go into model building itself. I'll explain that later. Then we'll now talk about model building. So it's about model building, it's about training data to analyze. In some of these analysis, you do by just plotting graphs. In some cases, you need to train machine learning models to pick out, there's some trends, or there are some patterns that you may not really see, but the machine can actually see. There are lots of machine learning algorithms that you can now start training to identify that patterns, and based on the patterns it has seen, it can now make prediction. So for example, you have supervised machine learning and unsupervised machine learning. For supervised machine learning, you have a label. For example, I use this example very well. So if, let's say, it's like training a model is about teaching let's say it's like teaching the child what to do. So you can bring like maybe you have a dog and a cat. You tell the child this is a dog, and you tell the child this is a cat. So that when the child comes and sees a cat tomorrow, you can say, okay, oh, this is a cat. You've shown me that this is a cat before. I can now say this is a cat. You can say, oh, okay, you've told me that this is an elephant. So whenever I see something that has a big ear with a long nose, I should be able to say it's an elephant. So that is similar to model building, training models. Okay, yeah, you provide what they need to learn about. Then, so that when they see it again, they're able to say, okay, this must be this must be this. Okay, then that's for supervised. But unsupervised, you don't tell the child, like let's say your child, you don't tell the child what a cat is, or what a lion is, or what an elephant is. It's about, okay, bringing different animals, and based on different features, you say, okay, group this animal into different categories. So the child, if in this case, let's just use child for example, the child can say, oh, anything that has whiskers, let me group them in one category. Maybe anything that has a tail, I'll group them in. So that's supervised. So you don't know what the thing is, but it's based on similarities between the data points. Let me put them in different bins. So, and some example of unsupervised is clustering algorithm. Then for supervised, I mentioned supervised earlier, you could have a classification problem or a regression problem. Classification is trying to say, is it like a cat or a dog? But in other cases, you want to predict a number. I want to predict the price of a house. I want to predict the production of a particular well. Those are continuous variables. So in that case, you want to go for a regression analysis rather than a classification. Classification is, would it be cold today or will it be hot tomorrow? But regression will be, what will be the temperature tomorrow? What would be the temperature today? So using that, so that's how you differentiate between classification and regression. So let me just look at some chart. I'm seeing some chart. Let me see. Okay, that's fine. That's not for me. I just wanted to be sure that I have all the, yeah. Okay, that's fine. Then after building your models, at least you have built your model to identify different things, then you want to then evaluate your model. So you want to evaluate your model. How good is your model? Is it doing well? So you want to get good predictions. If you, for example, if you have a model that out of 10 items, it's able to predict only one correctly, that means that model is not good enough. So you want to go for something with high percentage probability or prediction probability, right? Then once you train your model, you've evaluated your model, you deploy your model, but you also track the model. So when you deploy your model into production, you want to see, yes, for example, I train a model that can tell me if this is like different lithology, if it's a sand or shale. I want to also monitor the model. So when I deploy the model where maybe to an interface where somebody can just bring in their well logs, and by clicking a button, it will say, oh, this is shale, this is sand. You also want to monitor the model. Is the model really doing what I want it to do? Is it mispredicting? So for example, you bring something and it says sand and it's supposed to be shale. You say, okay, is the model really doing what it wants to do? So do I need to upgrade the model? Do I need to retrain the model? Do I need to get more data? So those are some questions you start asking. So that's in general what a data scientist do. Then I can say, okay, let's go into the methodology. So if as a data scientist, yes, you have an idea of a broad range of tasks that a data scientist would do. So I want to say, okay, if I want to start analyzing the data, I'm part of a business, I want to analyze the data, what do I do? First of all, you want to understand the business. Business understanding is very key. What do they want? What questions? What's their pain point? What are they trying to answer? Then we go into analytical approach. So what approach? Now, if I understand the problem, and there are different approaches when you want to start doing analysis. So I want to ask, where do I want to be? What do I want to start with? What do I want to do? So the business understanding will help you make that decision. Then if you understand, okay, the business problem, what I want to solve, oh, there's a decline in production. Okay, that's a question. So how do I approach that? Then you cannot say, okay, what data do I need? Because everything about it is about data. So you need to get good data that kind of analyze, okay, that tells you, that leads you to the question. For example, if I want to, let's say if I want to predict a housing price, for example, if I say I want to be able to predict if I am given, let's say, a house location. So is it in Lagos? Is it in Delta? Or if it's in Lagos, is it on the island? Is it on the mainland? Those are some factors that contribute to the price of the house. Is it a bed? Is it a one-room apartment? Is it a duplex? Is it a flat? How many rooms does it have? Does it have a swimming pool? So those are the kind of data that relates to what you need. But if you say you want to do a project that analyzes, that you analyze housing price, and you're going to get maybe information about something that's not related, you have data, but it wouldn't really relate to what you're trying to solve. So you need the information. So you need to know what kind of data you need to answer that question. Then when you understand the data you need to collect the data. So in most of the times in data collection, in collecting data, you might also need to go back and refine. For example, I want to collect data for a particular project. I discovered that, yes, even though this is the right data I need to get, but it's not available. I can't get this data to answer this question. So you might need to go back and say, okay, do I refine the kind of data I need? Then when you get the data, you now have to understand what kind of data have I gotten, data preparation, then model. So let me just go into explaining them one by one. So the first one is defining the issue, right? Then what problem are you trying to solve? I've talked about that. Then you determine the approach. Okay, there are different approaches. So how can I use the data to answer the question? So let me just talk about some data analytics kind of questions. So there are different processes and stages in data analysis, and so I'll put them in form of questions, some questions you want to ask. The first one is, and they are based on their value they provide and the complexity and difficulty. The basic is descriptive analysis. What has happened to the data? So for example, I put the first descriptive question, what is the current status? In that case, it's descriptive analysis. So for example, you want to see, you are a sales manager. You want to know what is the current status of our sales. So sometimes you just want to say, okay, what is the sales data? Just create a beautiful dashboard and generate report. Okay, this is how, for example, I have different stores. Okay, this store is selling XYZ amount of sale. This person is, so you just have that, okay, general view of what is doing, what's happening with your data, what has happened in production. Because okay, let me see what's production like for different worlds, what's the production like for different fields. That's just descriptive. So that's why I say, when you start it, you can say, okay, do I want to go for a descriptive analysis? So based on the business question, do they just want to see what our sales is like? So that's where I come in. When the business question is very important. So they've employed you to come and do data analysis. Your first question is, what do you want? So understanding the business, when sometimes they just want, okay, I just want to see what we are doing. What's our sales like? What's production like? That's it. Then it could also be diagnostic. For example, they're having a problem. It's okay. They are bringing you as a data analyst or data scientist to come and see based on, we have, for example, we discovered that our sales have reduced. Come and help us understand why. In that case, you are going for a diagnostic, like a doctor trying to say, you come to the doctor and ask, oh, I have headache. The doctor will start asking you, okay, what kind of, are you having fever? How you sleep? So these are some questions you start asking to diagnose what the problem is. So in doing diagnostic analysis, you would also do descriptive analysis. That's why it's a step higher. okay, what has happened in a day, like, yeah, what has happened. So by pointing out what has happened, then you can now see you can now see some irregularity in your data, some things that are not following the trends. Then your question will be, okay, why did that happen? So in some cases, for example, why did sale decline in a quarter, for example, as a sales manager? So you want to start doing root cause analysis of the sales. So it's okay. So while I'm gathering the data, so if I want to do this kind of analysis, I want to gather a particular sales, like the product sales, what kind of customers buy XYZ products, what methods do they use, do they prefer online shopping, do they prefer physical shopping, what product do they want. So I want to say, okay, did customer complain about a particular product? So for example, let's say in the last quarter sales dropped. I want to know, okay, why did sales drop in that quarter? First of all, I want to do my customer segmentation to say, okay, is there a reduction in customer? First of all, why are they not buy? Is there a different product they are going for? That maybe that's why they are not going for this product again. So you want to start doing your market analysis. Are there other competitions in the market? Are there other better competitions? Could it be maybe they will have competition at the same time they have better prices? It could be a quarter, maybe in that quarter there was a general a downturn in the economy. So maybe the product you are marketing or you're selling are those high-end products. Okay, if you see that the economy is dropping and people can no longer afford this product, maybe that's why it's dropping. So you need to understand why there is a drop in your sales. If it's your production, why is there a drop in production? So this is how you go about diagnostic analysis, trying to understand the why. Then the next thing you have to understand, okay, if I've understood the why, can I predict what will happen next? So, for example, I said, okay, last quarter there was a downturn in sales. What can we predict based on what we've seen for the next quarter? Would there be so that's why you have to understand what happened before. So you can now use that to predict, okay, for example, if there's a general economic downturn, is it going down? So is it going further down, or is maybe just going down and it's coming up? So if, for example, if you notice that it's going to go further down, so you expect further decline in your production. So those are some of the things you start predicting. So that's where you come about predictive analysis. So if I understand why it happened, so what's based on what I've understood, is it going to happen again? Doctor, in geology, they say the present is the key to the past. In data analysis, the past is the key to the future. So if you understand what has happened before, you can now say, okay, and what's happening currently, you can now use that to predict what's going to happen in the future. So for example, what's the forecast for our sales next year? So and there's a lot of methods, and there are a lot of processes or methodologies to do this different analysis. So that's why you have to understand what the question is. So depends on the question you want to answer, will determine the data you get, right? Then the last is prescriptive analysis. So if I understood that, okay, what has happened before? So what has happened, and for example, I predict that, okay, sale is going to further go down. As a business, so I cannot start prescribing. So if sales is going down based on the idea, because based on, okay, let's say there's a general economic downturn, do I want to reduce my price? So, but you have to also, so those are some questions you start asking. Do I want to do maybe some promotional offers? Let's say people that buy, if I get it, maybe just, okay, I'm giving it 50% discount. So those are some of the things that you can start thinking about to further help. Do I need to improve my marketing to reach more people? So those are some questions. So when you start looking at prescriptive analysis, you have gone through all the different stages, and you can now start recommending to business. That's where business recommendation comes in. So, okay, you can now at least go to the stakeholders, go to the management. So this is what I've seen, and this is what we can do to help us solve this problem. Okay, so let me see. Let me just come back here. So now we talked about the analytics. So this first, we just talk about the business understanding and analytical approach. The next one is the data requirement. We'll talking about it. So what data do you need to answer that question? Where do I get my data from? How do I collect the data to represent the problems to be solved? And do I need, so the data preparation and transformation generally comes from transforming the data. So you've gotten the data, you've loaded it. So that's where data integration comes in. Then you have data preparation, you need to clean the data. In most cases, you could have, let's say, where numbers you have categorical values, they are stored in numeric columns. So those are some things you have to clean so you have uniformity in your data. The next part is you start doing your visualization, applying your visualization to answer the questions. Then you start training models. I talked about different modeling techniques before. So now, then you can now start making your prediction. You evaluate your model. Then you deploy the model. So when you have a good enough model that shows you the results you want, then you can now talk about deploying the model for use for production. The jargon would be for production, deploying the model for production. Then after deploying the model, in most cases you also get feedback from the end users or from the people going to use the model. Is the model doing well? So that's why in this you see a lot of lines. For example, data requirement is a back and forth process. Most of these processes are iterative. You go back in loops. If you don't get the question, you can go back to refine your business, find the data. So for example, during your data preparation, if you discover that I don't have enough data or a lot of data are missing, maybe a very important data I need to analyze my data is I go back to data collection to collect more data. So it just goes iterative. Then modeling, in some cases you train your model is not good enough, you go back and maybe reprocess the data at least until you get something good enough. Then in some cases, after you go all the way to feedback. When you start getting feedback, you find out that okay, this model is not doing it's not performing optimal as much as I want it to perform. You can go back and train your model again until you get a good result. For example, if you are predicting, let's say, somebody with cancer, for example, let's say you're in the health industry. If you predict somebody that has cancer, you predict that somebody will have cancer, and the person doesn't have cancer, and you start treating the person that's very detrimental. At the same time, you don't want to predict that somebody does not have cancer and the person has cancer. So the time the person is supposed to be training, the person wouldn't be training. The person will be treating the cancer. The person will feel like I don't have cancer. Then maybe when they discover it will be too late. So you want to get the right prediction at all time. Okay. So now we'll then move over to what tools. So I've talked about what you do as a data scientist. So now what are the tools you need as a data scientist? So first of all, I want to talk about visualization tools. So there are different tools. So these are non-programming based tools. So these are tools that you can download on your computer to start using. So basically, a lot of people have Excel. I think a Microsoft Suite is one of the basic skills you, as a young professional, as a student, you are required to have. So you can start with just get tabular data, start plotting graphs, start doing cleaning your data using Excel is a good place to start. And you can now go into more advanced tools like Power BI. Power BI is very, very easy and very intuitive. I find Microsoft product very easy to learn and very intuitive. So for example, if you know how to use Excel a lot, if you know how to use Excel, you should be able to find your way around Power BI. Power BI is it's easier to create plots and do things in Power BI personally for me than doing it with Excel. So you can create interactive charts. So that's a very key feature of Power BI and Tableau. You can create interactive charts using Power BI and Tableau. And so Power BI, Tableau, they are mainly the same thing. They do the similar things. It's more like having, let's say, in the oil and gas industries, like having petrol and having what's the name of the software? Let's say OpenWorks, or there's this other software that also does seismic interpretation. These different tools, they do seismic interpretation. So it just depends on which do you prefer, or you want to say Excel and Google Sheets. They're the same thing, just provided by different companies. And some companies, if you want to join some companies, they'll give you Excel to start with. Like they have the Excel package. In some places, you have the Google Suite. So it just depends on what you prefer. And also, for example, you want to work, what does your organization use? Because you can get the free version of Power BI, you can get the free version of Tableau, but there are also paid versions of these different softwares. So you can say, okay, start with the free version. At least it's a good way to learn and just pick up the skills. That's the way to go. Then we'll go focus on some other programming language. So when you hear about programming language, there are lots of languages out there. There are like a lot of programming language. You have Python, you have R, you have SQL, you have Scala, you have Java, PHP. And this is where a lot of people get confused. I know, I think some time ago, somebody reached out to me that I want to learn data analysis. Okay, I said, that's good. Well, so what have you said? And I've started already. I was like, okay, so what language are you learning? And the person mentioned PHP. In my house, like PHP, data analysis, data science, how does it relate? So these different languages are used for different things. So for example, you want PHP, HTML are focused on, you can use them mainly for building websites. You have C++, C sharp. If you want to do maybe software development, app development. So they are used. But if you want to start looking at data analysis, data science, I recommend learning SQL. SQL is for database management. So remember when I showed you what a data scientist does. So you talk about data. So when it comes to managing database, managing the data, you want to focus on SQL. So it's called structured query language. Yeah, so just to put out at the end of this presentation, I'm going to give like a quiz. I want to see who will rank highest in the quiz. So just listen very well, because everything in the quiz will be centered around what I've said during this call. So we have different programming language. So we talk about SQL for database management. Then you have Python and R. Python, I recommend a lot of people learn Python, because Python, you have like almost so end-to-end capability using Python. So you could do data transformation, data cleaning, data visualization, machine learning building, training machine learning models, deploying models using Python as well. Then R is mainly for statistical analysis, things like that. So it depends on the company. Some companies, if you join some companies tomorrow, they use more of R. But Python is like a general purpose language that you can use Python for different things. You can use Python for web development. You can use Python for data analysis, software build, so for automation and a lot of things. So that's why I actually recommend Python. Start with Python, and it has a very easy syntax that you can easily pick up if you are really interested. Okay. Then also talk about libraries. I think some people had some questions initially talking about Matplotlib. So you have Python is the programming language. There are some libraries that you can use for different things within Python. So I have Python. Python is a high-level programming language. When we talk about programming languages, they are high-level and low-level language. So let's use it at a spectrum between, let's say we have human language, like English language, for example, at one end. And at the other end of the spectrum, we have binary. I don't know if you remember or if you know about binaries, where you write zeros and ones. So let's say computer language is a binary, human language is English language. These different programming languages, they fall between somewhere within the spectrum. Some languages are closer to the machine learning, machine or computer language, and some languages are more around the human language, like that's English. So Python is, so the ones closer to the computer languages are called low level languages, and the one closer to the human language are called high level language. So Python is a high level, or it's a high level language. That means it's easy to, you can like write in English mainly, but you have to understand the basics. So and if you want to use Python, there are different libraries within Python that you can use to do different things. So for example, pandas and NumPy. NumPy is used for numeric computing. If you want to do calculate metrics, vectors, do different calculations on numeric computing, you want to use NumPy. So you can import. So when you download your Python, then you can now access NumPy inside your Python environment, whatever environment you've set up. I'll go into details when we go into the live session. Then you have pandas. Pandas is for structured data analysis. So I want to be able to, maybe you can use pandas to visualize your table. I want to see, okay, well, how does this table look like? You want to use pandas for that one. Then you also have visualization libraries like Matplotlib and Seaborn. These are good libraries to visual. I have the data, but how do I plot to see what I want to see? Like in the last the first session, you see the line chart, the well-log chart, the facilitator was talking about. All this were built. You can also use pandas to visualize, but if you want to start doing a lot of customization, you better use Matplotlib and Seaborn. They give you better visualization. You also have things like Plotly. Plotly is also a good library. Somebody also asked a question about visualization using maps. With Plotly, you can plot data points on a map. For example, let's say I want to plot production in a particular region. I could use a map plot to say, okay, maybe this region has higher population, so you can maybe either use a scattered plot using your bubble chart where where you can see that maybe the countries with the highest production of oil, for example, will have bigger chart. So by looking at the map, you want to focus on the ones with the bigger one because those are the ones with higher production. Or you could use this in form of heat map where the thicker color, I'll show you examples later, where the thicker colors represent higher production, things like that. But we'll go into details when I show you some of these things. Then when you start talking about machine learning, you want to look at scikit-learn. With scikit-learn, there are lots of machine learning algorithms where you can just call and train your models. Then we also have keras for deep learning. Then for machine learning as well. Then deep learning, you want to focus on TensorFlow, PyTorch, and this might be a lot confusing at this point because we're not going into details. But what I just want you to take from this session is don't focus on trying to remember everything. Just have an idea about it, understand it. When you need to learn, when you need to start applying it, you can she mentioned something about, I attended one course sometime in July and it talked about scikit-learn. Let me go and see, what does scikit-learn involve? So when I talked about machine learning, classification, regression, so there are different algorithms in scikit-learn that you can use to train models. Then I talked about also R. I mentioned most of the time I talk about Python, in this case R. So if you want to look at R, for example, a good library in R for visualization is the ggplot. It also has some very nice plot visualization if you want to learn R. Okay. So now let's talk about development environment. So I've talked about Python, I've talked about library. So where do I write Python? That's another question, is how do I write Python? Do I just pick it up on my computer? Do I write it on, let's say, text file? So there are different environments where you can start writing your code. For example, I want to write a Python script. I want to write R. What environment do I need to write this code and see? So the first one is the most common one and where a lot of beginners go for, because it's very interactive, is Jupyter Notebook, where you can run your code and see the result. There are some environment that you run the code, you don't really see it immediately. You have to see it on a different interface. But with Jupyter, it's easy to interact. And also, this is, for example, you can write your code. I would do a demo of how a Jupyter Notebook looks like. I can also send you a link to where you can, like a web-based Jupyter Notebook. Then you can also easily plot visualization and you see it in the same notebook. That's why Jupyter Notebook is good. Okay, then you can have Jupyter Lab. It's like Jupyter Notebook as well, but they have kind of slight differences. I wouldn't want to go into that for now. Then you have RStudio. RStudio is used so if you want to write R, you want to use RStudio as your development environment, so you can download. So for Jupyter Notebook, to access Jupyter Notebook, there are different ways to do that. You can either download Anaconda. Anaconda is a software distribution where you can use it to access different programming languages and different development environments. That's for Anaconda. Or you could download Visual Studio Code. Visual Studio Code could also be part of Anaconda package, or you can download it separately. It's developed by Microsoft, but when you want to download Visual Studio Code, you have to download or install Python separately. Why I recommend that people just go download Anaconda is because you already have everything inside. So all you need to do is install Anaconda and open up Jupyter Notebook. But if you want to go start start installing Python separately, you want to install Visual Studio Code, then you have to install Python separately. And it can come with its own complication. You want to create a new environment, virtual environment, it can get complicated. And most of the time when you download Anaconda, for example, some of all these libraries you need to work with are already pre-installed. So you don't need to go reinstall. All you need to do is import them whenever you want to use them. Okay, but if you want to start installing Python separately, installing Spider separately, you have to now start import. If I want to use Pandas, I have to install Pandas first. I have to install Matplotlib, I have to install NumPy. So most of the time I just say, okay, download Anaconda. It's easier. Everything as beginner, when you go into advanced things, you can now start using the other ones. But as beginners, just to reduce your complication and complexity, download Anaconda. Okay, then you also have PyCharm. Those are different development environment and Spider. But for the sake of this, for beginners, you could just start with Jupyter Notebook. Okay, then these are the ones you have to download on your computer. You can also access some of these things without downloading anything on your computer, but you have to work on the web. With these ones, if you have it installed on your computer, you don't need internet connection to do any of your analysis. But there's also the cloud-based environment for Jupyter. This one is usually for Jupyter Notebook, but you need internet whenever you're working on this. So you need we have two categories. We have Jupyter Lite and Google Colab. The first speaker showed you Google Colab. For this, the demo later, we'll be using Jupyter Lite, and I'll share a link on how to get to Jupyter Lite, but that will be much later. So now we've talked about tools for data scientists and everything. Let's now go into what is data. Data, as simple as it is, data is any valuable information. Sometimes information might not be valuable to you, doesn't mean that it is not valuable. So then anything you think that is valuable, it could be number of people. For example, the number of people attending this class, for example, it is the data that the organizers can use tomorrow. So okay, if we had this course, you can also get the data at different timestamps. Okay, at the beginning of the class, we had XYZ amount of people. Halfway into, so those are data. That information might not be useful for you, but the people organizing this session, it's important for them to help them plan for next session. So these are some information. So any information that you think is useful is data. Then we have two types of data. We have structured and unstructured data. Structured data are data that are cleaned. You have them, like in most cases, it's just similar to what you have in Excel. When you show an Excel, you see rows, you see columns. They are organizable. You can easily search on your data. But why unstructured data is everything else. They are not organized. They are just you have different things. You could have data from, like, for example, most cases when you get data from different sources, it could be unstructured. So you have to go through the process of structuring the data in order to even start doing your analysis on them. So I wouldn't want to read through. Just as a visual representation, data, when you see something organized in a good, so those are structured data. They are usually in Excels and CSVs, and they're easier to work with. In other cases, you have things like PDF. For example, you have a PDF. There are information in the PDF, but you can't just carry analysis on them. So it has to go through a process of structuring. You have to go through a process of transformation in order to make it a structured format. Okay, so that's for structured and unstructured data. So now let's go into, to talk about data. So what's a data set? Data set is a structured collection of data. So from what I've said previously, data set is structured. When you hear about data set, you want to talk about structure. Okay, and let's talk about different data structures. So we have tabular data. That's something you have like in your rows and columns, like what we've seen before. So you have like rows. The rows would represent different observations. While column would be the attributes. For example, let's say player A. In this case, player A has like 20 points. It has 41 minutes. So it's everything. All the attributes is related to player A. So each of the rows represent different players. Then we also have hierarchy data or network data. These are data that are represented in graph-like format or network. For example, you have, let's say, use social media, for example. So if, for instance, I believe all of us, we are all on one social media platform or the other. It could be LinkedIn, it could be LinkedIn, Facebook, Instagram. So let's say the middle person here is, let's say, the central person. You could say, okay, this person has a friend of another person. So it's showing relationship between different properties. So you say person A is a friend of person B. Person A likes cooking. Person A listens to this kind of music. So you are representing this kind of information will be difficult to represent in a tabular form. So that's why we present it in a kind of network form, like more like a graphical form where you can easily focus. You can say, okay, I want to get everybody that knows person A or everybody that follows person A. So you can pull that out together and say, okay, let me do analysis based on people that follow a particular person. Or say, okay, I want to pull out everybody that listens to a particular genre of music. So it's like a database as well, but it's stored in a graphical form. But the way you can query a structured database, you can also query a graph database. For structured database, like tabular database, they are stored in tabular data structures, and you can query using SQL, structured query languages. While for graph kind of database, you want to you want to store them, you want to query them using Cypher, Neo4j. It might be new to you, but those are some query languages that you can use to query a graph database. You could also have network database as well. So you have like you can see in most cases some of these individual boxes would be structured data. I think that's when you start looking at different tables in with SQL database. You want to know the foreign key, you want to know the primary key. So those foreign and primary keys are the keys that connect two tables together. For example, I can have a table of colleges. I have different information about the college, where the college is located, what the courses they take. Then I can also have department in that college. So I want to know the department. So the department will link to a particular college. For example, I can now say, let's use school, for example. Let's say in Dataset we have FUPRI, we have PTI, we have DELSO. So you could say under college you could have information about DELSO, have information about PTI, have information about FUPRI. Then under each of them, you could have department as well. So you also have a table of the different departments linked to the different colleges. So under each department, you can say, okay, what courses do they take? Who are the instructors? Who are the students? So you have a different table for students. So everything all linked back to colleges. So if you can pick up a student and see how it links back to the college they attend, or the university they attend, or the department they are. So these are kind of they are structured data, but they can be connected in hierarchy in different hierarchy. Okay. Then now we talked about different data sets. Now let's talk about where do I find data. So first of all, before you start thinking about where to find data, you have to understand the different levels of data, different types of data sources. So you have the open data set and open data set sources. So these are data sets that you can, as a beginner, you can just go pick and start using. They have proprietary data sets and data sources. So these are the data sets that, like for example, if you have like a producing field, for example, in Nigeria, you won't see the data anywhere because those are proprietary data. So you should also understand the restrictions to these different sources of data. For example, if you're working with a proprietary data, you dare not go share it out there. If not, you can be locked in the prison. So if you're working, I've seen people trying to work in a company and they try to publicize the data they've shown, or the data set they have worked on, like the insight. That's a punishable offense. So if you're working with a company, you know that whatever I'm doing is just for me, myself alone. I don't have to share it. It's just for me and the company and whoever is interested in that data. But there's also licensed data. Licensed data could also be public data sets, but they have some licenses attached to them. So there's some data sets that they are public, but they have maybe like CC by 4, CC by 3. So some of them are, okay, you can get them as long as you credit the owners, that's fine. You can use it to do anything you want to do. You can use it to produce a commercial product. Like some data, even if you get them, let's say I get a data set and it has a license that I cannot commercialize that product. So even if I cannot commercialize the data, whatever comes out from the data, so whatever data I've trained, whatever I've done using that data, I cannot sell it because it's, and so those are the license. You have to understand licensing agreement. So when you're going out for open data set, you also want to look at the licensing agreement, licensing data. So you, for example, you can start like, this doesn't concern me and I'm just a student. You can start doing something and you build something that is very important that everybody wants to use. But you have to now go back to revisit the license. Oh, because of it has this license, I cannot maybe sell this product. So, or you cannot sell. So sometimes you feel like some of these things are not important as beginners, yes, but you don't know how far your journey will go. You can develop the next biggest thing, but you have to be careful. What data set do I use to generate that? What licenses are associated with that data set? So that would also help you. So I thought to mention that. So now we'll talk about different data sets. There are different platforms you can get data sets. It's unfortunate that within Africa and within Nigeria in particular, you hardly find data. I think that's the biggest challenge I have with people. Like a lot of learners, okay, I want to learn, what kind of data do I practice on? As Nigerians, is better because you understand the Nigerian, let's say Nigerian basins, Nigerian geological setting. It's better to want to start working with data set. But the truth is, the reality is that we don't have this information, we don't have this data available to us. So then we can now start taking advantage of publicly available data sets. So there are some open data sets like the data.gov. I think it's US based. So you can go there, search for different kind of data. It's sometimes not only limited to even data analysis and machine learning. In some cases, you have to clean this data to make it machine learning or data analysis ready for you. But if you go to data.gov, I think I have it. So you have data catalog, you have data.gov, So you have governmental data set as well. Then if you go on cargo, you have more structured, clean data ready for analysis. Just go on cargo. If you want to do something on petroleum production, production information, just type production. You see lots of data. Then you can now select which one do you want to use. And the thing is, cargo organizes a lot of competition. It's also a good learning, a good learning material for people as well. So you could just go pick up data, maybe a particular data set. You can see what other people have done with similar data sets. So you can now go there, start building inside. Okay, if someone that has done XYZ, I can now pick up that sign, do something. At least it's a good learning. It provides data and also a good learning resources because you see other people's code and what they've done with the data, so you can guide your thinking on what can I do with this data. Then you also go on Google, just type Google data sets on your Google place and you see different data sets as well. You could just go search for the different, if you want to do such something on water chemistry, you could just type water chemistry and you see different data set associated with water chemistry. So you can take a snapshot and you can just go search for these different data sets and you can just start working on them already. Okay, so now we go into the live session, but before we go into live session, let me I have a short quiz for people based on what I've said. If you could just go through, scan this QR code, it will take you to the place where we can start the quiz. So we also have leaderboard. If you have questions, please by all means put them in comment section. So before you ask me questions, let me ask you my own questions to be sure that you understood everything I've said. So if you can start the scan the QR code. So let's see. So join the quiz. So the quiz is timed. So you have 20 seconds for each question, and you were looking at getting the right answer at the fastest time. So we have a leaderboard to see. So we have about 31 people here, so we can start. So the first question, what data science categories enables you to present data in a form of chart, plots, and map? It's 5 more seconds to go. 2, 1, that's it. So let's go. So we have a lot of people picking data visualization, and yeah, that's the correct one. So if you pick model building or data integration and transformation, that was wrong. So the next question, yeah, so that's the correct answer. The next question, which data science category enables you to train the data, analyze pattern using suitable machine learning algorithms? So train data and analyze data using suitable. You have 3 seconds, 2, 1, go. So this is what people, model building, some people picked model monitoring. It's good nobody picked data visualization or model deployment. So let's see the answer. So the answer was model building. So if you pick that, good. Then let's go to which of the following statements about Jupyter Notebook is available. Oh, it's correct. Which of the following statements about Jupyter Notebook is correct? Is it only available if you list it on your local computer? Yeah, some people picked Jupyter Notebook. So let's analyze it. So if you pick Jupyter Notebook is only available if installed locally on your computer. I showed you just so that you can use Jupyter Notebook on the web as well, so your cloud-based systems, so on either Jupyter Lite or Google Colab. So the correct answer for that one is Jupyter Notebook support. You can visualize your charts within your Jupyter Notebook. So if you pick provide storage of mass quantities in data lakes, you don't use Jupyter Notebook for data lake or database management. You use SQL. And Jupyter Notebook is not a commercial product. It's free. It's open source. Okay, so let's go. Which plot is used to plot data points over time? Which plot is used to plot a series of data points over time? A lot of people pick line charts. So let's see. Yeah, that's the correct one. Line charts is used to plot data points over time. So now let's go to the fifth question. Which data science category do you extract, transform, and load data? Yeah, if you picked the first one, you're correct. Other ones you're not correct. So let's look at our leaderboard. So Ofubo is leading with Alice gotten the five questions correctly. followed by a, please, I can't pronounce your name, followed by Temidayo, Obina. And so let's continue. So we still have some more questions to go. Just wanted to see your progress. Okay, so now the next question is question 6. Which open source tool supports more than 100 programming language? Yeah, I think I didn't really talk about this, but let's see who can get this. I kind of mentioned it, but not so much. Open source tool. Let's see. Yeah. Okay, so I think, this is kind of because I didn't really explicitly mention this during the presentation. So the correct answer is Jupyter Notebook. Jupyter Notebook is a short form of Julia. Julia is a programming language. Python, Julia, Python, and R. So you can use a lot. With Jupyter Notebook has been upgraded that you can use different languages on Jupyter Notebook, right, using your Jupyter Notebook. So that was the correct answer. So the 7th question, which of the following options determines your choice of language to learn? Which of the following options determines the choice of the language you want to learn? Yeah. So it depends on what you want to solve. So that the correct answer is problems to be solved and who you're solving it for. Can I just go on quickly? So what is the primary purpose of SQL? SQL is structured query language. What's the primary purpose of SQL? The correct answer for that is to query your data. So it's structured. So the answer is in the name, structured query language. So it's for querying structured data. So the 9th question, which of the following library is not mentioned as a high-level visualization library? I kind of mentioned it during, which is not for data visualization. Okay, so if you chose TensorFlow, you're correct. Matplotlib is for data visualization. I mentioned it during the presentation. Seaborn is for visualization as well as Plotly for visualization. So the correct answer is TensorFlow. It's a machine learning or deep learning library for deep learning or artificial intelligence. What's the best way to represent network data? What's the best way to represent network data? Network data. What's the best way to represent network data? Yeah, so if you choose as a graph, you're correct. I mentioned like using of Facebook or social media representation. So it just shows network of different things. So it's present as a graph. Okay, so let's look at our leaderboard. So we have Fadere leading, followed by Okechukwu. They have the fastest time. So Fadere had the fastest time. Okechukwu has the second fastest time and answers the most questions correctly. So let's continue. We have 5 more questions to go and we'll get our final winner. Okay, let's continue. So which library is used for machine learning? Which library is used for machine learning? Machine learning. So it's quite interesting. We have a lot of people picking pandas. Really? Pandas, we have scikit-learn, we have matplotlib. Pandas is used for data transformation, and I showed when I talked about scientific computing, use pandas and NumPy. Matplotlib is strictly for visualization. So the correct one here is scikit-learn for training machine learning models. You have different machine learning algorithms inside scikit-learn. Okay, so let's continue. So the correct answer there is scikit-learn. 4 more questions to go. What term is used to describe a structured collection of data? What term is used to describe a structured collection of data? Okay. So data set. So if you follow the presentation, you know the correct answer is datasets. Okay. To share your notebook with others. Let's see. Yeah. Let's see. Yeah. So a lot of people pick Excel. So Excel is, you can use it to share the raw data. But when I talked about sharing notebooks, so I'm going to talk about it later on. So when you, after doing your analysis, you can export your Python notebook as PDF. So the correct answer is PDF. Yeah. Okay. So which among the following is a cloud-based Jupyter notebook that can be saved on Google Drive? Cloud-based that can be saved on Google Drive. So the answer is in the question. The answer is in the question. The answer is in the question. So which of these? So we have I talked about two main type of cloud-based system. We have Jupyter Lite and we have Google Colab. So when you talk about Google Colab, you save it on your Google Drive. I didn't say it explicitly during the presentation, but yeah, just intuition. So the answer, correct answer is Google Colab. So the last question, I believe, is what is a key characteristics that defines a data scientist? What is a key characteristics that defines a data scientist? The emphasis is key. The key characteristics. Yes, a lot of people got the answer correctly. So curiosity and problem-solving mindset. Yes, you can have the ability to work with large data set, but if you don't have, you're not curious, because everything's about curiosity and trying to solve problems. That's why you begin. What's the business problem? Yeah. So let's see the overall, the top. So we have Fadire as the winner of this quiz, followed by Debayo, and we have Newton VI as our third winner. So the hardest question was which format here, I think, because I didn't talk about that. But well done. I hope you found that useful and interesting. If you have further questions, I think I'll just take some questions now. Then we go into the live demo, and we come back to wrap up, if that's okay. So let me start answering some questions on the chat. I saw the chat earlier. How does data science differ from data analysis? Data analysis is a subset of data science. So as a data scientist, you still do data analysis. You analyze your data. As a data analyst, you focus more on data visualization, that and so maybe some data transformation. So there are different levels of data transformation. So there's one that happens in the data warehouse before it goes into the data warehouse. But when you extract the data, you still need to do some cleaning and transformation to suit the analysis you want to do. So that's what a data analyst would do those kind of cleaning of the data and visualizing the data. But a data science, so look at it as, let's say I want to take a snapshot of an area. If I want to snap a building alone, I just want to see that building. That's what a data analyst will focus on. Let me focus on this building. But a data scientist want to look at everything. I'm not looking at only the building. I'm looking at the surrounding building. Let's say you have an estate, for example. A data analyst would be like, I want to focus on house A and everything about house A. But a data scientist will be looking at the whole estate. I'm looking at not only that house A, I'm looking at all the surrounding houses. I'm looking at the security. I'm looking at the landscape. So see it as data science is a broader version of data analysis. As a data scientist, you still do data analysis. Does that answer your question, Christopher?
Yeah, thank you very much. You have really done justice to the topic. I have some good questions to ask. Number one is this. I am a data scientist, for example, and I've been offered in a domain area that I'm not familiar with. How do I succeed as a data analyst? Question one. Then question two, artificial intelligence integrated into data science. If I'm a data scientist, can I call myself as a machine learning and artificial intelligence expert?
Yeah. Okay. Thanks for that question.
Or do I need to go and specially learn or study machine learning?
Okay.
That
Yeah.
is the second question. Then number two question, building data pipelines. I'm and what tools are being used in building data. My last question is this. Talk about supervised and unsupervised machine learning. Now, how do one go about getting this experience? Thank you very much.
Okay, so let me start from the first question about data analysis in a field you are not familiar with. I think the most you can apply the traditional, let me visualize the data, but there's a limit. That's why I talk about curiosity. You need to understand what the data is saying. Let's say I'm working with gamma ray logs, for example. If I have a high gamma ray reading, what does it tell me? I can do visualization, but I may not be able to interpret the data. So you might not be able to get the full domain knowledge about that data. But at least you need some information. If I have different columns, what does this column represent? What some features might be related to some features. So you want to understand what they mean. So first of all, you have to understand the data. You can't start doing analysis on a data set you don't understand. If you don't have domain expertise, one way is you can now start and learn. I have this column. You can now speak with a domain expert. Okay, at least I have a fundamental. What does this attribute mean? What does this column mean? What would the values in this column tell me? For example, you want to plot. So for example, in the well log example we saw earlier, I have gamma ray, I have neutron density, I have neutron porosity, I have density log. But how can I? What does if I can plot it? But what can I say from it? You don't have. But that's why you have to have understanding of the domain you're working with. In some cases, by just googling it, you might understand some of the data. And sometimes when you get data set, there's an explanation about the data set. But you can also communicate. That's why collaboration is very key in data analysis. Collaborate with people that know the data well. Let them give you an understanding. And sometimes when you do your analysis, you can now go ask them, okay, this is what I'm seeing. Is it consistent with this field? Does it make sense in relation to this field? So yeah, but you definitely need background, at least the data science knowledge. You have data analysis. It helps you know what kind of processing do I need to do, what kind of visualization. But you still need to make sense of whatever you do. You need domain knowledge, and that's why you need collaboration. If you don't have the domain knowledge, you can collaborate with people that have the domain knowledge. Then the next question about machine learning. Data science incorporates a lot, like I see, data management. So it also depends on your organization. In some organizations, you have separate machine learning engineers. So you can, as a data scientist, you can do some machine learning models, but you also need to collaborate with the machine learning engineers. In some companies, you do everything. So who is a machine learning engineer? Is somebody that can train machine learning models, and it's not just about superficial modeling. Machine learning is big. You start talking about artificial intelligence, talking about the different machine learning algorithms. So everything is just about names. Most of the time, I'm not really one that focuses on certification, qualification. If you know how to do it, I think for me that's more important. And how do you showcase that you know how to do it? That's another question. So if you know how to train machine learning models, you understand what machine learning is, the different machine learning. So if somebody gives you can't say you are a machine learning engineer and they ask you what are the types of machine learning, you don't even know. So these are some basic things you need to know. So it can get more complex. But as a data scientist, you incorporate both machine learning, model deployment. In some companies, data scientist has nothing to do with this model deployment. But it's just depending on the company structure. But generally, you have like this broad range of skills. And then talk about learning. It's just about learning it. You want to learn a model, supervise. It's just about, I think, as simple as Googling machine learning, you'll find out what machine learning is and different types of machine learning. There are lots of resources out there. A good platform you could use, Medium, it's a good educational material where you can learn about, at least just type machine learning, types of machine learning. It's good enough. At least you can learn, okay, what's supervised, what's unsupervised, what are the types of unsupervised learning, what are the types of supervised learning. Informations are out there. Again, I have my YouTube channel where I talk about these different things. So you can check it out also to have an idea of some of these different concepts. Somebody had a question in the chat. What's the best way we can learn this Python program? What's the best way? It depends on what works
You
for
skip
you.
one of my questions, the pipeline.
Okay,
Pipeline building. Yeah, pipeline.
pipeline.
Pipeline
See,
data building.
it depends on what you want. There are different tools out there. I think for me, you can also build a pipeline using Python. What's a pipeline? It's more like you can customize your pipeline how you want it to be. A pipeline can be, I get data, I transform the data, I train a model. So there are different pipelines and can be hosted on different platforms. But I think for me, the easiest way I can build pipelines, you can build, so there are libraries in Python that you can use to build pipelines.
Okay, ma. Then also, you need to clarify. I have a point of confusion here. Now, if I'm trained as a data scientist, because I'm confused between data scientists and a machine learning, so artificial intelligence experts. Are they the same set of human being, or they are different entirely? If I want to be a machine learning expert or artificial intelligence expert,
Okay, so I think
do
you're cut.
I need to go and be a data scientist or be a data scientist learning or artificial intelligence expert automatically? I need qualification.
Yeah, so so for example, data science looks at every broad range of the spectrum. But for example, you want to be a machine learning engineer. That means you are zooming in on model building. So it's, for example, it's about having an overview of, okay, what machine, understand, know how to train models. But sometimes there are a lot of processes that goes on behind model training model. When you talk about it, so looking about machine learning, there's artificial intelligence, where you start looking at deep neural, so machine learning, deep learning, when you start looking at convolutional neural networks, deep neural networks. So machine learning engineers just more like they are. If data scientists can do machine learning, but a machine learning engineer does more. So it focuses on more of machine learning. So a machine learning engineer might not necessarily know data management or data transformation or even data visualization. All is focused on is, let me train a machine learning model, let me train a model that does XYZ. So if you have that kind of person, so you need to also know how to collaborate with other disciplines. So you also a data scientist, so you can pick up from where the data scientist will leave off. So at least it's more, just more like that. It's more focused on just model building. You don't really need to understand data transformation or things like that. But it's just about, okay, yes, my own focus is model. Anything about model building, be it deep learning or machine learning, that's where you find them. I don't know if that answers your question.
Yeah, thank you very much.
So what's the best way to learn Python? There are lots of materials out there. There is YouTube, there is Coursera, there is Udemy. But the problem with some of these platforms, if you don't have a direction, you can get lost. I've been there before. I've been there, I've done that. I think that's why I started my YouTube channel, because there are lots of, so Python, as mentioned, Python is a general purpose language. Python can be used for data analysis, data science. It can be used for automation. It can be used for software development. It can be used for web development. It can be used for game development, product testing. So it's depending on what do I want to learn. I wouldn't want to be a data scientist and I'm going to learn Python for web development. That's misplaced priority. So first of all, understand what do I want to learn. You can, if you know how, if you are you know how to, you can do a tailored search on maybe Python for data analysis. And there are lots of people out there that you can get confused. So platforms like Udemy or Coursera, they offer like a structured learning platform. But on YouTube, if you don't know what you're searching for, you can get lost. So that's why most of the time I recommend at least go for free courses. Have an understanding, things like this that NAPI organizes. They've organized lots of training, so you can attend, at least have an understanding of what you want to do, so that when you're searching, because if you don't know what you're searching for, you won't even know when you get what you're searching for. So that's why sometimes it's good to follow people. So follow people that know road. So follow people that have been there, that understand the process. So you could start from Coursera. There are some nice free courses. You can Python for data analysis. That's a good place to start. I have my YouTube channel. I have like a playlist dedicated to Python for data analysis, from beginner level down to at least data visualization. And I also have machine learning as well. So it's just about looking out for the right information, following the right people that can give you the right information. If not, you can get lost easily.
So while I joined, you were trying to differentiate between data science and data analysis, which brought you to this particular slide. So I want to ask a question: that is it that a data analyst will perform all this data management, data transformation to model monitoring, or like both data analysis and a data scientist can do both of them?
Okay. Thanks for mentioning that you just joined. So if you follow, so my session is focused on data science. So whatever you see on the board, these are the job roles or like what the tasks of a data scientist. For a data analyst, they mainly focus on data visualization, analyzing data. Sometimes it could include some part of data preparation, data transformation, but not the one that happens in it. So there's data transformation that happens before the data is loaded to a data warehouse. So as a data scientist or a data analyst, that's why I say you need to learn SQL. SQL is structured query language. So you need to know how to query data. Most companies, you have data stored in a warehouse. So as you need to know how to get the data from the warehouse. So for example, if you want to learn SQL, that's why you have a structured learning platform, but a structured learning path. Because if I want to be a data scientist, a data analyst, I don't need to go learn SQL on how to create database. All I need to know is how to query the data from the database. The job of data management is data engineers. Let's go back to different. So there are different job roles within data space. So if you look at the first two, for example, that's where you focus on data engineers. So they do that a lot: data extra management, data transformation. Then we have data analysts. They pick up from the second box into data visualization. Yeah, so data visualization, when you look at data preparation, some parts, so not the detailed data transformation. After the data has been loaded, the data analyst will query the data and do data visualization to understand the data and brings out insight. Then a machine learning engineer will pick up the data and transform, build the model and evaluate the model and deploy the model. So now I've talked about three different roles: data engineers, data analysts, and machine learning engineers. But the job of a data scientist covers everything. So it also depends on the company you're working for. Some companies can say, okay, let's have our data engineer separate. But as a data scientist, like a full-fledged data scientist, you should understand database management, data transformation, data visualization, model building, model evaluation, and model deployment, down to model monitoring and assessment. So data scientist is like a bigger umbrella that covers every other thing. Diagnostic question. Diagnostic is trying to understand what has happened with your data. So if I know something happened, if I have something, I want to understand why did it happen to the data. That's diagnostic. So I put in a link on the chat. If you can just click on it, it takes you to, it will bring you here. So let me just click on that.
All right, ma. You were saying something earlier that when you have many plots, that you'll be able to know the one that give more information. I was thinking earlier that when we have a 3D plot, that's going to show like all the axes. Like maybe for instance now in geophysics, whenever we are having the 3D plot, it's showing like all the size of the object we are talking about. So why do we still have to like have many plots when we can have just 3D and we are going to have all the information that we need?
With 3D plot, what's the maximum attribute you can plot in a 3D plot for? Because we have our X, Y, Z, then you have, let's say, the color bar. But what if you have more than, let's say you have 10 attributes? So first of all, you want to see, before I even plot my 3D, what are the most features that can show me, lead me to my answer? So instead of, for example, I'm working with a data set that has like, I have 15 attributes. Will I start plotting everything one by one on 3D? Yes, that's if you have time. But sometimes you just want to, I just want to focus on what I, so on Anthony again, the subject matter expertise is very important as well. So it's not everybody can plot 3D plots. It's just about, everything just about, yeah, there's no one size fit all. Just about what suits you, what you think would answer your question better. Some people make this 3D plot, but it's not really, it's not as clear. In my own opinion, like, yes, when you want to look at it, if I want to communicate this with, let's say, oil and gas experts, the plot I'll be showing them would be this plot. First of all, this plot would be very key for them, and maybe that's one. It's just about, yeah, there's no formula to it. It's just about what is the most important thing you want to show. If you feel like 3D plot works better for you, by all means go for it. So, and they are different. You can use heat map. You can use different things. Okay. Okay. So now, if you click on the link I shared on the group, it should take you here. So it's not about here. This is a Jupyter Lite. You start having to download anything on your computer. You can access this. So I'll just open up a Jupyter file. So this is a Jupyter. This is how a Jupyter notebook look like. It's more like a Jupyter lab or Jupyter notebook. This is like the, but I just wanted to show some key things. So in this case, you can rename your chart. Just come here, rename. Let's say Nape Worry chapter. Let's just call this Nape Worry. Yeah. So I've renamed my chart. This is how you rename your notebook. So in this bar here, you have save. So it will be good. So if you can follow along with me as I'm, because most of the thing is you can just listen in, but you may forget. But if you do follow through as I'm going through, it's easier for you. So you can use this to save. I can use this to add more cells. I can use this to cut cells. I can use this to copy a cell and use this to paste a cell. So when you put your cursor over it, you see what it means. So you have copy, you have cut, you have add new cells. Then you use this to run the cell. Then you can, for example, you have something running, you can stop it. Yes, so let's just go. So when you talk about Jupyter Notebook, there are two main things you need to know. There's a code block and there's a markdown block. A code block is used to write your Python code. Why your markdown is used to write explanation about the code. So for example, I want to say, okay, I want to for some people to come and okay, look at this notebook. I can say, let me explain this notebook. For example, if I show you the last thing I showed initially. So when I came here, all these things, if I did all this write up, we're done using Markdown, because it's like an explanation about the code. So this is a title. This is where you run the code. So the code is used to run the code, while the Markdown is just used to write an explanations. So with the Markdown, it's just about coming here, click on the code and change this to. So for example, let me name this, let's say, and with Markdown, you can do where you have if you work with Microsoft Word, you have heading 1, heading 2, so you can use that as well as in Markdown. So let's say, let me put this, to put an heading, let's say heading 1, you use 1 hash. If I use 2 hash, let me see, you see the difference shortly. So let me use capital heading 2. If I use 3, heading 3. So if I run this, you see the difference. So heading 1 has the biggest, it's bold, like it's the top level. Then you have heading 2. So just by just specifying your hash, would know, okay, is this under an heading 2? We are under an heading 1, things like that. Then you can use you can make things bold by using double star in between inside those. So if I say, let me make this is bold. If I run this, you see that this would be bold. Let me write one without bold, without bold. So if I run this, you see that they are normal text. So you can write normal text. So if I run this, you see that this is without bold, but by using the double star sign before and after, it boldens that. If I want to maybe italize something, let me make this italics. You use your double underscore. Okay, no, that's also bold. No, one underscore. So you can bolden with double asterisk or double asterisk or double underscore. But for 1 underscore, it will be italicized. I can also I'm talking about Markdown as well. I can also use bullet points. For example, by using 1 star, let's say bullet 1, bullet 2, bullet 3. So if I run this now, I'll see that I have bullet 1. So you can use this. So it's just about knowing how to add things. So I can also, if I want to write an equation like present, so if you look at the previous notebook I showed, there's a point I put some equations here. To do this, you use your dollar sign. So I'm just trying to rush through. So let me say z is equals to x over y, and I close it with a dollar sign. If I run this, it makes it like an equation. So those are some of the things you need to do. So you can also do, let's say, numbered lists. You can do number 1, let's just make it 2, let's make it 2, 3. So so you notice that they are all numbers. So these are different things you can do using your Markdown, just about different levels of writing. I just kind of explaining your notebook, because sometimes if you have a notebook without with a notebook without explanation, it might get confusing. While the code is used to run code, for example, I want to run, let's say, do normal calculation, 3 divided by 10. I would do that using a code cell. So why is this still running? Let's give it time to run. Okay, so yeah, that's so to write your code. I don't know why this is not running. I think that's when you do live sessions like this, something tends to not work. Yeah, but generally, if you write
Sorry.
yes.
How do I do this Nape worry folder? How did you get in there?
So if you send the link I sent you earlier,
Yes, I opened it.
yeah, just like so you just create a new. So it brings you back to, let me see. So if you, let me see if I can take me back to this place. So you just click on. So I renamed. If you've been following, I had to rename that. It didn't just give me that initially. So it gives you something like this. So
Yes.
if I want to write a Python, so I just click on this.
Okay.
If you click on it, it opens a notebook for you.
Yes, it did.
Then you can now come here, right click, and rename your notebook.
Okay.
So if I want to do, for example, let me add another one. If I, let's say, do the same thing on, you see the difference. So this is, if I do this on a Markdown, you see the result that will come out. So it's not code will be executed, it just shows me that. But if I do it on a code block, that's where my code will be executed. So I can do calculation using my code block. So because most of the time when we come for this kind of sessions, you just hear a lot of advanced things and you can get confused. So what I want to start doing is, okay, let's start from the basics. If I want to work with Python, I've shown you beautiful notebook that did a lot of complex things, but you need to get the basics to get here. You won't get here in a day. So it's just about, I just wanted to, okay, let's have a good starter that you can go build on after this class. So I've shown you how to, if you don't have to download anything on your computer, you can ordinarily generate this Python, this Jupyter Notebook. So let's just talk about basics of Python. So by the time when you want to start talking about Python, you want to start with, first of all, variables. Variables are containers that are used to store information. Okay, so I can have a variable called x. X is equals to, let me make my x equals to 10. So if by running this, I'm telling my computer that my x is 10. So whenever I call on x, the computer will return 10 because I've told my computer that my x is 10. Yeah, so that's, let me, so like I said, Markdowns are used to give information about your code. So I can now say, let me make this a Markdown, but I want this to be, let's say, first level header and say these are variables. Okay, so now I'm talking about variables. So variables are used to store information. Then you can now start writing notes on it. You can say, okay, variables are used to store information. Let me just make it short form. Yes, so you can, so I'm right. So that's, if you pick up this notebook, you're able to follow through what these are. Then you can now come and say, okay, variables can also be overwritten. So if I say, let me tell my computer, my x now is no longer 10, it's 50. If I call on x, it's going to return 50 for me. Okay. So let me say before I run 50, let's say I run x now is equals to, let's say 4. Yeah. What do you think my x, if I print out x now, what do you think my x would be in this case? If you have questions, if you know, just comment. What do you think my x would be in this case? Anybody can answer. What do you think my x would be in this case? I'm looking at the charts.
X equal to 50.
X will be equal to 50. Why would x be equal to 50?
Because you already set a variable, and you said earlier that variables are used to store information, and from the earlier ones you wrote, x equal to 10, then the x will now give us 10, x equal to 50, x will also give us 50.
Okay,
so that's why, man.
Okay, let's check if that will be correct. So let's see, what did X give me? X is 4. Do you know why? Because of, it depends on the order which you ran it. So I ran this one first. You see, its output is 2. And I ran that X is equals to 50. After I run in X equals to 50, I now ran that X equals to 4. So you see that this is the latest one I've ran. So that's what will be stored in the computer memory. So even though I arranged it like this, it depends on how do you run it. What's the hierarchy of you running it? Yes, in this notebook, this one came before this one. But if you look at the output, it's showing that number 4 was the latest one I ran. So the computer will be recognizing X as 4 because this is the last thing I ran. Then if I come here again and run this again, so now it has changed. So this is the latest one. The computer will see X as 50 this time. So it just depending on what's the word now? How did you run it? What's the process? What's the hierarchy on which you ran it? So X will assume the latest, the most recent variable you ran. You get. So what's the latest one I ran? So if I look to know, as a trick to know the latest you ran, just look at the output. So this just shows you, okay, this is normally I ran this first, then I ran 2, then I have 4, I have 6. So the latest here is 6, so my X will be 50. Next thing I want to talk about data types. So these are the building blocks. These are the building blocks of Python, learning Python. You want to know what is variable, what are data types. So the next thing is data type. So there are different types of data in Python. So I just want to, so I'm using so I talk about, let's talk about integers. I have float, let me talk about floats, let's talk about strings, and let's talk about booleans. Okay, so let's go. So now we're touching the different data types one after the other. Okay, do you want to talk?
Yeah, I noticed something. When you type 3/8, it was giving you 0 point something. Now that's
what? Can you put your
so question? Does it mean yeah, I say I noticed that when you type 3/8, it gives you when you run it, it gives you the 0 point something as the answer.
Yes.
So does it mean Python can do mathematics without you putting the formula?
Yes, so that's a formula already. 3/10 is a formula. So divide, so they are different. When you want to do calculation, you have addition, subtraction. So let's see. So you have addition sign by using let's say addition, let me use this. Addition, so is this a code? This is a code. Let me do addition. So let's do subtraction, multiplication, and division. Let me just focus on these 3 different ones. Okay, division, you will use your division sign. Multiplication, you will use your star sign. Subtraction, just use minus. Python understands that. Then addition, you use this. So I want to show you something now. I'm writing, this is supposed to be Markdown, but I'm running it in the code. Let's see what would return if I run this. It's going to return an error because Python does not understand. So that's why you have to know how to use Markdowns. So this is supposed to be Markdown, but I'm writing it as code. So another way to, if you want to still do this, but you want to leave it as Markdown, you can use your hash. So it shows you are commenting the code. So it's called commenting in Python. It's more like Python, don't run this part of the code because it's just a comment. So you can add comments to your code block. So this time I run it now, it's not an error. It's more like using this hash. It shows that, okay, avoid this part of the code. Okay, so it's just about avoiding this part of the code, but this is not what I want to do. Somebody's asking about the notebook. So if you go to my I have a GitHub page, so I have a lot of materials as well. So let me just go on my GitHub. So you just go on GitHub, and I have different materials for different things. So I have a repository. So GitHub, as a data scientist, this is something you want to start having because it helps you kind of just collect your code together for you in a place. So I have like petrophysical analysis with Python. So it's a repository I'm building. So it's not yet complete. At least you can start from there. I also put a link to where I get the data from. So this is just first part. I don't think I have the exact one I should, but this is a similar data set that you can just go through at least this different visualization. You can talk about well log and that well log visualization as well. I think similar thing I showed initially. Then you can also, I think I have this one. This just shows your lithology. So at the end of the day, you can start building lithology, adding your lithology to your visualization. So in this case, I'm plotting, okay, based on these different areas, I'm plotting, okay, based on lithology. So this is sandstone. So this is the scale. So I can say this is my sandstone lithology. You can say, okay, within this region where I have high resistivity, I'm having sandstone. So this could be a good representation. I have high resistivity, I have low, high neutron. So you just have to start exploring this region to see what you have. So you can just plot lithology as well against your depth, where you can now start plotting your porosity, water saturation on the same plot, but you have to build that calculation. So if I put a link to my GitHub as well, you can find different notebooks. Also, I have a repository for learning as well, some different Python trainings as well. So if you click on it, I have different training platforms. For example, this was a recent training I did as well for APG. So you could just go and start Python for data analysis. I have like the basics as well there. On my YouTube channel, I also have the video explanations for this different notebook. So it's just about explaining the different so this is what I was going to talk about, Python data types. You have it on here. So if you're this person asking for the link to notebooks, I could share the link to this notebook as well. You can use it for your trade. You can just go through it. At least I added some comment as well, so you can use it to analyze it as well. Just go through. At least it's a lot explanatory. I have some more detailed one as well. Let me just come here. If you come on this one as well, Python. So this is for more like Python for data analysis as well. So it's more focused using geophysics, geology kind of thing, related terms to create yours. I can also paste this as well for you to go download, and at least it's explanatory as well, so you can explain. So I just wanted to cover Python data types here. So I talked about three different data types. 4 different data types. So integers, just know that integers are numbers. So when I did x is equals to 20 now, if I print my x, it's 20. So if I want to know what's the type of x, I want to know what kind of data. I have 2 people raising hands, Ehi and Henry. Please unmute yourself.
All right, ma'am. Thank you, ma'am. I want to ask. You said we should go to Jupyter Light. So I want to ask that can we also use like other software for doing the data analysis
I can
too?
hear you clearly.
All right. You said something earlier that we should go to Jupyter Light. So I want to ask, are there other software or applications that we can use apart from Jupyter Light? Or
Yes.
like maybe
Yeah,
line?
if you follow my presentation, so let me just go there. If you follow my presentation, there are different softwares you can download Anaconda, so you have it on your computer. So these are just web, because I don't want to start having to tell people install that on a call. So that's okay. Let's just quickly use Jupyter Lite. So if you're most of these other things I was showing you was using my VS Code, where I've installed everything I need to install. But it won't be productive if you want, because you can start going into errors, and I don't want to bring that complexity. So if you have the time, I also have a video on my channel where I walked you through how to install Anaconda and how to launch a Jupyter Notebook using Anaconda. But for the focus of this class, so that we don't have to spend time trying to install things, so this is the same notebook you will still. So when you download and install those things, you still have access to your notebook, and this is still not a Jupyter Notebook will always be a Jupyter Notebook. Everything we'll be doing here, you can do it there as well. Does that answer your question?
Yes, ma'am.
Okay, so let's continue. So if I want to know what data type do I have for a variable. It's just about calling type, opening a bracket, and putting, let's say, x. So I want to say what kind of. It shows int. So integers are actually, the short form is int. So it shows that data type is an integer. On the other hand, floats and numbers are decimal numbers, floating points. So if I say, let's say 20.5, if I print y is going to be 20.5. I want to see what's the type of y. Type, which just shows me is a float. because of the point I have introduced into it. Very simple. Like I said, Python is as simple as English language. You don't have to do complex things. Then why strings? Strings are numbers and not numbers, sorry. Strings are letters. So if I want to store, you use it to store things like name of a person, a name of something that can be a number. So if I want to put name, my name is Promise, and they are case sensitive. My name is Promise. So if I print out name, it will return Promise. So I've told my computer that name is Promise. So whenever I call name, Promise will be returned. But if I want to say what's the type of variable, what's the type data type stored under name, so I just called name. It's told me that name is a string. So it's very simple. So we've talked about integers, float. We talked about strings. We could also go and talk about booleans. Booleans are just yes or no, true or false values. So if I said, okay, let me make it, let me just call it. So variables, you can store variables as anything. The way I stored my name as, I can make my name J. So it depends on what you want to call as J. So just remember that it always returns that. Okay, so I can say W, let W be true. So it has to be capital letter, true. So enter my print W, W is true. So I can say what's the type of W? You should return it as boolean. So it shows that my W is a boolean. Okay. So let's go back. So that's you can carry out mathematical operations using these different data types. For example, my X is so if I do X plus Y, not X plus Y, it will return X plus Y for you. So if I do X plus Y to be, what was my X? My X was 20. My Y was 20.5. It gave me 40.5. That's a calculation. I can do X minus Y. X minus Y. It gives me minus because Y is bigger than X, right? I can do, let me do Y divided by, let me do Y times X. Or let me use X, let me do X times 2. Will give you, that's X times 2. 20 times 2 is 40. Okay, I can do, let's do X divided by 2. So this is division sign. X divided by 2 is 10. Okay, I can also do, let's do X divided by 3. This gives me 6.6666. But there's something in Python where I can say, give me only the whole number. So if I do X divided, so if I want to get only the whole number, use X divided by, use double division sign, then do 3. It will return only 6 for me because it's telling me that's the whole number. But if I want to return what's the remainder, so if X divided by X is 20, X divided by 3 is 6, which will remain 2, right? So if I want to return only the remainder, I do X, use this percentage sign, do 3. It will return 2 because that's the remainder. So you know that this gets, so I can use comments to add to this. So returns whole number. And then I can use this comment sign to do returns remainder. Is this clear enough? I couldn't copy the link to your Git link. Yeah, so yeah, if you just click on it, it will take you there. So these are some of the things you can start doing. If I want to do something to power, you can do, okay, let's say X power 2. So I want to do X power 2 will be 20 times 20, that's 2 raised to the power 2. I can do X raised to the power of 2 by using 2. Let's do this to get the power. So I can use my hash sign to say to say I'm commenting, say power. So I can do this. X power 2 will give you, that's 20 times 20, 40. I can do X power 5. It returns that's X times 10 times 10. That you can use some other math. So if you want to do some other advanced calculations, so I talked about there are different libraries to calculate, to do some mathematical formula. You could just import maths. So there are different libraries for different things. Maths. Do I have to install this? Okay, I can do maths. So if I want to, for example, the same thing I've done, I can do maths dot square roots. Let's do roots of 49. I hope this works. So it gives you 7. So math is a library in Python that you can use to calculate mathematical formula. So everything we've done using this, you can use it with math. You can also do math dot addition, or let's do math dot pi. So I want to return the pi. Pi is 22/7. No, let me see. Do I have to do that? Yes, just call math.py gives you the pi value. So you can just go, if you want to know about any library, just go type math, type Python library, Python. You see the different things you can do with the math library. So if you click on the documentation, so every library has a documentation. It's more like whoever built it, writes a documentation. Documentation gives you information about that library. So these are different things you can do with the math function. You could get the math library. You can, let's just go through. You can do ceiling. So if you want to round a number, you want to round it up or round it down, you could do sine, math.floor. Let's just look. So you can just go read through at your convenience to say, okay, what are the things I can do with a math library? So at least these are basic things you can do with Python. So with this basic, it doesn't matter if it's for data analysis and if you want to use Python at all, you need to understand Python basics, and this is where everybody comes together. Then when you start going more deep, then you can now split. Okay, these are different math functions you can use. So people that talk about learning Python, a good platform you can also use is W3 Schools. Come to W3 Schools and click on Python. So if you follow through, I think it's a good place. You start from the home, follow through down. You at least it gives you, and it's a free resource. If you're not sure where to start from, just start from what is Python. I think let me put that in the description as well. And you can also try out some Python. You can try it yourself as well. So you can just come try yourself. So whatever the example they give you, you can go click on try it yourself. It takes you to a different window with a Python thing where you can try. So this is not a Jupyter Notebook. This is how most Python development environment works, and you run it here and you see and with this you cannot really plot graphs with this one. Yeah, so this is how, but that's the good thing about Jupyter. As you're seeing the code below what you're running and you can go through. But this is a good place to at least learn Python. Okay. Is that clear enough? I think I don't want to go more deep so that I don't get to confuse people, but I just wanted to at least touch the background of Python so that you have the basic understanding of Python. At least with this, it's a good place. At least it's just about more like whetting your appetite so that you can build up from there. At least you can see all the things that you can do with Python. I've shown you, the last speaker has also shown what you can do with Python. And I'm giving you, okay, this is where to start from. If you don't know where to start from, this is where to start from. I've shared some of my materials. I've shared some links where you can go start from. I think that's a good place to start, and you can build it up from there. You can connect to me on LinkedIn. Connect with me on LinkedIn as well. And if you have questions, I have a community I'm building also for young scientists as well, where I share whenever I come across information as well. I share with them as well. So if you go on my link, let me get my LinkedIn page as well, so you can connect with me on LinkedIn, ask questions, and whenever I try to answer as quick as I can. So that's why whenever I'm free enough, I try to respond to most messages I get. Yes, but you can, let's see, view profile, just get this out. Connect to me on LinkedIn, and we can take it up from there. I think I've dropped my YouTube link earlier. So I think that's a good place to start and for you, and it's a good place for me to close this out. If you have questions, I think the floor is open now.
Yes, sorry, mine is just like clarification.
Okay.
I tried. Please, can you go back to the to how to do the headings on this Jupyter?
Okay.
That is that data types heading number 1. Good. I just want to know is it star or something?
Hash.
I did hash, it didn't work.
What did you put space after the hash before what you want to write?
Yes, I did.
Is it on a code block or on a Markdown?
On a code block.
No, so if you want to write headings, so hash on a code block, it shows that don't run this part of the code. Python exempt this. So all the places I use hash, you see that it just exempt that, just say Python skip this part. But if you want to make it heading, it has to be on a Markdown.
So how do I do it on a Markdown?
So just change, so just click on the cell, just come up here, change from code to Markdown. That's all. Does that work?
Yes, I've done the Markdown, so I just type on it.
Yes. So Markdowns are used to write stories, write information, that anything that is not code. That's what you do with a Markdown.
So I just did it.
And does it work?
It didn't do the big, like.
Do you want to share your screen? Or do you want to take a screenshot and put it on the chat? Let's see a screenshot of what you've done.
No, I just wanted to show big, like these variables to be the same font as this variable.
So when you do it, you just run it. So for example, if you do like this, see this one, but if I run it, it now shows how I want it to show.
Yes, perfect. So last question, how do I adjust the size?
You can adjust the size. So if you want to make it, it's just about right. So you cannot adjust the size. If I want to make it smaller, a second heading, I just put double hash. So you see that it has reduced.
Okay.
So, yes. So if I want to make, so it's just more like hierarchy. Heading 1, so everything under heading 2, heading 3 will become smaller. Heading 1. Yes. So if I let me make this variable as well. Then make this a Markdown. So you see the difference between the one with, so this is definitely bigger than this, and you can go all the way to 6. You can go all the way to 6. So you see the way it's getting smaller, but you still see it's a thing like that.
I see. Thank you very much.
Okay.
There's a question there to say, can Python be used to produce or generate geological maps?
Yes, you can generate maps with Python. Let's see. I don't have any example to show. Let me see if I can bring up an example. I have just a minute. So you can generate map. You can plot contours. Let me see if I can quickly pull out an example of what I've done before now. Okay, so let me just show that this one, another one is running. So this is an example of a map on Python. So in this case, I was just doing analysis on, and this is an interactive map using Plotly dash. Plotly is a library I mentioned earlier. So there are different maps. So in this case, I'm plotting, I think it's just about a restaurant based in a different region. So I can plot them as long as I have their X and Y, or the longitude and latitude. So I can easily plot and click on there. So this is a clustered map showing I have 3 points. So instead of having to show lots of information on it, I can just plot different information on that and say, okay, and this is showing that, okay, this is a clustered marker cluster, where I say, okay, I have within this region I have 13 restaurants here, because this is a restaurant data. So if I click on it, I'm seeing all the restaurants, and the more I zoom in, you're seeing the different restaurants. This is a map. This is you can also plot let's see, let me make this this other one is let's see, in this place I'm plotting a choropleth. So this is also showing, let me see what's showing, the number of good restaurants. This is a restaurant data. It can be all and gas, but this was just like the most representative. Shows, okay, the number of restaurants in a particular region. So the deeper color shows, so you see, come here, you see the deeper, so the thicker the color, the more the value. So everything is customizable. In this case, if I'm doing this analysis, first of all, I want to focus on the ones with the darker region, like, because that's how I have more good restaurants. Why? So this just shows you that color plate. So I'm plotting this on the map. This is using Plotly, and it's very interactive. I can zoom in, I can hover on it to see, okay, what do I have there. I can click on it to see what I have there, and there are different ways you can visualize maps as well. So let me see if I have other maps I need to show for this as well. So these are all maps. So yeah, you can also show map. So there's also a library for data analysis. So the way we have pandas, we have Jupyter as well for data analysis, and you can plot map data using Jupyter as well.
Okay, Promise, can you hear me?
Yes, ma'am.
Okay, there's one question saying, how can he install a Python? There, another person is saying that how many data scientists can be employed in a company to work? How many at a time? Then the other one says, how can he install Python?
That's why I've said it. So if you've been on the call, there are different ways to go about it. I would recommend going through Anaconda. Going through Anaconda, because everything, you don't have to start installing things in bits. Because if you want to start installing Python, if you install a Python, you want to also install an environment. So you want to install maybe a VS Code, install Jupyter Notebook. That's a long process. But if you install Anaconda, you have the what are you calling now? If you install Anaconda, everything is already inside. So let me see if I can. Let me see Anaconda. If you install Anaconda, for example, everything is already inside. Let me see. No, not kind of Python. Not this. So this is how, if you install Anaconda, this is how it will look like when you launch your Anaconda. So you have access to different environment depending on what you want to do. Depending on what you want to do, you have access to, for example, you can, oh, this is small, but yes, you can, for example, you see PyCharm I talked about, you see Jupyter Lab, Jupyter Notebook, you even have Visual Studio Code. By the time you have installed Anaconda, you have access to different tools you can use. And you don't have to start installing. Most of the basic fundamental packages are already installed in Anaconda, so you don't need. So if you also go, I think I have a detailed video where I explained how to install Anaconda and how to install these different things. So let me see if I can share that link as well. Where's that link? Let me see if I can share that link. So this is it. Let me see. Open this. So if you come, if I'm sharing the link now, this is what it looks like. So I have all the information, the links to download it, and how I kind of walk you through how to install it from scratch, and how to even start using it. So if you skip that, so I'll put the link in the chat box as well. So everything you need to do is there, and I have, so you can skip the ones you don't need. I have some channels, so if you want to use Anaconda, for example, downloading Anaconda, you see the information there. So if I want to say I want to install an Anaconda, just come here. You see all the information that you need to, where you need to go. So I walked you through, okay, when you go on the website, what do you click, how do you go from there, everything you need to do to where you install. If you don't want to use Anaconda, you want to use Miniconda. Miniconda is also a smaller version of Anaconda. I have the Miniconda version as well. So all the informations are all there. So you can just click on the link and it takes you there. I don't want us to start looking at how to download these things. So that's why it's okay, let's just use Jupyter Lite for this class.
Have you dropped the link on the chat box so
Yes.
they can get it?
Yes.
Okay. Okay, so the other question that says that how many data scientists can be employed in a particular company to work at the same time?
Okay. The person that is asking, let me ask you, how many students can be employed in a school at the same time to study? Let's say they can be admitted to study geology or study any course in a school. Who asked the question? Can you answer my question? Huh?
Christopher Isong, can you answer? Okay, can you just go ahead? I don't think it's
okay. So what I was trying to get is depending on the capacity of the company. So for example, some schools cannot take more than, let's say, 50 students at the same time, while some schools can take up to 1,000. So it depends on the company. So some companies are bigger, some companies are small. It also depends on the business needs of the company. If they don't see a data scientist or data analyst as something that is very important, they may just say, we don't need them. So everything is just dependent on the size of the company and the problem the company is trying to solve, and if they see a need for it or not.
Okay, so on that question, say, assume I want to remove decimals from a long column of data in Excel. Can I do it in Python and apply it on Excel?
Apply in Excel, I don't know how that, but with Python, you can easily convert. For example, now I have this, let's say my y is a decimal. If I want to make it a whole number, all I need to do is I will say integer. It's called casting. So converting that y to converting the y to a whole number. So you can also use the math function. I told you about the math function. If I do math.ceil is a way to round number up. So I do math.ceil while, so it's more, this is more like rounding it up. It gives me 21. But if I do math.floor, that's rounding it to the lowest number. I do math.floor, it will return it to 20. So if you're working with when you start working with data tables, you're using a different library. So this is just basic Python. So when you start working with tables, you're now working with pandas, and there are different functions in pandas that you can use. So this is like the logic, but this is not how you do it with pandas. You have to use the panda series dot as type, so you're converting it to a different type. So yeah, but you have to get to that level. I don't want to. That was going to be a lot for this class. So this is just about basics. But when you start working with pandas, there are ways to convert from a particular data type to a different data type.